Hello everyone, welcome to the 10th video of MATLAB Simulating Essentials. In this video, we will see the simulation of half-wave control type of rectifier with RL load and freewheeling diode. We will use various components present in the library browser. In the previous video, we have seen the simulation of half-wave control type of rectifier with RL load. So I will just run the simulation. Open the scope block. So here you can observe output voltage and output current waveform. In the positive half cycle of the AC supply, inductor stores the energy, whereas in the negative half cycle, this inductor will release its energy. So we will get some part of output voltage waveform in the negative portion as well, and due to this, the average voltage across the load will get reduced. So now let us check what happens if we connect freewheeling diode in parallel with this load. Take the diode present in the specialized power system library. Rotate it and connect it in parallel with this load. Save the changes and run the simulation. Open the scope block. So here you can observe the change in output voltage and current waveform. When we apply the gate trigger to this thyristor, it will jump into the forward conduction mode. So this output voltage waveform is similar to the resistive type of load, and we will not get any output voltage waveform in this negative portion. So in this current waveform also you can see the changes. Because of this freewheeling diode, the output current waveform gets improved. So when we use a freewheeling diode in parallel with the load, we will not get any output voltage waveform in this negative region. So value of output voltage, average output voltage will get increased, and along with that this current waveform improves. Now let us check the voltage and current waveform across this freewheeling diode. So for that, take the bus selector block. Connect it to the measurement port of this freewheeling diode. Copy the scope block. I am connecting to the first terminal voltage across this supply side. To the second terminal, connect the output voltage across the load and open this bus selector. Remove these previous signals and select diode current and diode voltage. Connect these terminals to the scope block. So now save the changes and run the simulation. Open the scope block. So these first two waveforms are of input and output voltage, and this last two waveform depicts the current and voltage across the freewheeling diode. So in the positive half cycle of the AC supply, when we apply gate trigger to this thyristor, it will get forward bias and it will start conducting. Whereas this cathode terminal of this freewheeling diode is getting connected to this positive terminal of the supply side. So this diode will get reverse bias. So you can observe in the positive half cycle of the AC supply, negative voltage across this freewheeling diode. So during this time, inductor will store the energy. So whereas in the remaining negative half cycle of the AC supply, this inductor will release its energy through this freewheeling diode, because this freewheeling diode will provide least resistance path for this inductor. So the output voltage across this diode will be 0, whereas this inductor is releasing its energy and its energy is getting gradually decreasing. So here you can observe the output current waveform across this freewheeling diode, which is also gradually decreasing in nature. So that's all from this video. Check out the description box for the quiz and do answer them in the comment section. Thank you for watching this video. Like, share and subscribe to the channel Start Scratch, and do check out our other videos to learn similar skills throughout bite-sized content.